Firing rate control. It comes under load demand control part 4, which comes under boiler control system. This diagram is showing firing rate control scheme in detail. We shall be using this diagram in each subsequent slide, but whenever you feel convenient, you can always come back to this detailed diagram. Firing rate control. Firing rate control is also known as combustion control. The function of this control loop is to adjust the fuel flow and the combustion air flow to the boiler to meet the firing rate demand from the load demand control system. A typical firing rate control scheme is shown in the figure attached. Request. It is hoped that this session is going to be useful to you. Please press like. Please subscribe. In general, the firing rate control loop employs two closed loop controllers. First, the total fuel flow controller, and second, the total air flow controller. The firing rate demand serves as the fuel flow set point for the fuel controller, which uses the measured fuel flow as the feedback signal to close the loop. The controller output regulates the fuel flow to the boiler. In the case of oil or gas fired boilers, the fuel flow is controlled by modulating the fuel flow control valves, and the fuel flow is measured by flow meters installed in the fuel supply line to the burners. For pulverized coal or cyclone fired boilers, the coal flow is controlled by modulating the speed of all running coal feeders, and the feedback flow is represented by the sum of the speed of the running feeders. The airflow set point is derived by modifying the firing rate demand signal with an oxygen control signal to account for the excess air required for optimum combustion. The optimum airflow is normally a function of the boiler load. The required excess air set point can be developed from a variable that is proportional to the load, such as the boiler steam flow signal. An oxygen controller is used to compare the oxygen set point to the measured oxygen content in the flue gas and produce the oxygen control signal. The firing rate demand is multiplied by the oxygen control signal before it is used as the set point for the airflow controller. Thus, the airflow set point changes proportionally as the oxygen signal varies with load. This is why it is often said that the boiler airflow is controlled by fuel-air ratio. The airflow feedback signal is the sum of the air flows through the parallel air paths to the wind box, and in the case of coal-fueled boilers, the sum of all primary air flows to the individual pulverizers is added as a part of the feedback signal. The airflow controller output is the air demand signal, which controls the boiler airflow by regulating the inlet vanes, the inlet control damper, or the actual speed of the forced draft fans. There are two major considerations in controlling the boiler firing rate. First, the furnace must be kept air-rich under all operating conditions to ensure a safe combustion environment. This is accomplished by comparing the measured airflow to the fuel control signal, and also by comparing the measured fuel flow to the airflow control signal, so that on load increase, the airflow increase will lead the fuel flow, and on load decrease, the fuel flow decrease will lead the airflow. The net result is that the boiler airflow is higher than the fuel flow at all times when the boiler is in operation. Second, the airflow through the furnace must be maintained above a level that is sufficient to sweep off any unburned combustibles that could possibly accumulate in the air and gas flow paths. A minimum airflow limiter is used to keep the airflow control signal from drooping below the minimum level before the airflow control signal is applied to the control drives. Request: it is hoped that this session was useful to you. Please press like. Please subscribe.